In this video, we're going to talk about polysaccharides. If we think back, a monosaccharide is basically one sugar unit. A disaccharide has two sugar units, or two monomers. A polysaccharide, the word poly means many, so it's made up of many sugar units, or many monomers. The first type of polysaccharide that we're going to talk about is starch. Now, starch is found in plants, and one of its major roles is to store energy. Now, there's two types of plant starch that you need to be familiar with. The first one is amylose, and the second one is amylopectin. Amylose is made up of glucose monomers. Amylose forms a straight chain of glucose monomers. So amylose would look like this. It would connect all of the glucose monomers in a straight chain. Now the bond that connects the glucose monomers is an alpha 1,4 glycosidic bond. So I'm not going to draw the entire glucose monomer, but I just want to show you why it's called an alpha 1,4 glycosidic bond. So this is carbon 1 of the first glucose unit on the left, and here we have carbon 4. So it's a 1,4 bond. Now you need to be familiar with the alpha and the beta forms of glucose. In the alpha form, the OH group on carbon 1, it's facing the downward direction. The beta form of glucose has the OH group pointing up. So as you can see, this is the alpha form. So thus we have an alpha 1,4 glycosidic bond. So amylose only has this type of glycosidic bond. Amylopectin is different. Amylopectin contains branch structures. So it still has a straight chain, but occasionally you'll have chains that will branch off from the main chain. So that will be an example of amylopectin. Now let's talk about the bonds in amylopectin. So the straight chain part of amylopectin has the alpha 1,4 bond, as you could see here. But now, the branch part of amylopectin has an alpha 1,6 bond. So this is carbon 1, 2, 3, 4, 5, 6. And that's connected to carbon 1 of this sugar unit. And this is still an alpha bond. So amylopectin contains two types of glycosidic bonds. The alpha 1,4, which is responsible for the straight chain part of amylopectin, and the alpha 1,6 glycosidic bond, which is responsible for the branching that we see in amylopectin. Now the next type of polysaccharide that we need to talk about is glycogen. Glycogen is a polysaccharide that is made up of glucose monomers. Now we said that starch is found in plants. A good example of starch will be potatoes. Glycogen is the starch that is found in animals. Now glycogen is highly branched. Like amylopectin, glycogen has alpha 1,4 glycosidic bonds and the alpha 1,6 glycosidic bonds, which are responsible for branching. Next, we have cellulose. Cellulose is a polysaccharide that is found in plants. And its role is not for energy storage, as in the case of starch and glycogen, but it serves for structural support. It forms very long fibers in plants. Now let's talk about the bonding that's found in cellulose. As we could see here, this is a beta bond since it's going up. And it's between carbons 1 and carbons 4 of the glucose monomers. So cellulose links up the glucose units by means of beta 1,4 glycosidic bonds. So that's what you need to know regarding cellulose. Another polysaccharide that you might be tested on is chitin. Chitin is similar to cellulose, but it's found in insects as opposed to plants. And it has a structural function as well, as opposed to energy storage. So that's basically it for this video. So now you're familiar with the most common polysaccharides, such as starch, amylose, amylopectin, glycogen, cellulose, and chitin. Thanks for watching.